Hi guys, I hope you're well. Today we are solving this question. It is question 5, Maths paper 1, November 2013. I'll read the statement. Sketched below are the graphs of g of x equals to k to the power x, where k is greater than 0 and y is equals to the inverse of g. You see, when you have a g here to the power -1, it is actually an inverse of g. This shows that it's going to be the inverse. And people confuse this. When it does not have this negative, it looks like it's a prime. Then that is when you differentiate. See that when we get to differentiation, the chapter topic for differentiation. So in this case, when it's like this, g to the power -1, there it's an inverse. So this function is going to be the inverse of this one, of g. All right. They say the coordinates here, 2 and 36 is a point on g. It's a point on the graph of g. So here, this 2 is the value of x. This 36 is the value of y. When you have a coordinate, you have x and y. So they form coordinate there, 2 and 36 on the graph of g. That is what they told us. They said this is it's a point on a graph of g. It's a point on a graph of g. So here we have the inverse. So this graph here is the inverse of g. This is g. This is the inverse of g. Okay. Now let's go back to the statement. On the statement, guys, we need to remember that when we were doing exponents, when we introduced exponential graphs, we were using y is equals to, okay, just allow me to write here. We were saying y is equals to a to the power of x. Y is equals to a to the power of x. Okay. So now they are using k instead of a. So this a or k, guys, it is just a variable. It represents a number. So on the graph, they said k is greater than 0. So which means that would be like a is greater than 0. Now let's go back to revise what I did on the exponential graphs. I told you guys that, let me do this. And let's do the x partition clean there. So when x here, this is positive, when this is positive, we know that the graph will increase as you go to the right. When x here is negative, the graph will increase as you go to the left. That was what is happening. But for the value of a, when a is negative, when a is positive, it tells you that the graph will be above this horizontal line. The graph will be on this side, on this side, this side, on this side, on this side. When a is positive, so the graph is going to be on this side. It can either go like this if x is positive, or it can go like that if x is negative. But because a is positive, we know it's going to be on this side. Understand that? And then let me change the color. And then if a is less than 0, if a is less than 0, then this will mean that the graph will be at the bottom part, this side, below this line, below the horizontal line. So again, it can be like this, or it can be like that, depending on the on x, the exponent, if it is positive there or negative, as I have explained. As I have explained. And then yes, obviously this is not drawn to scale. But now they are saying a, on the question it says a is greater than 0. So because a is greater than 0, we expect our graph to be on the top part, above the horizontal line. And I've also noticed on that graph that x is also positive. See, x is the exponent is also positive. So this means the graph will increase as you go to the right. So here it is. Here's the graph. It increases as we go to the right side. See, when you go to the more you move to the right, the more the graph, the y value of the graph also increases. Like it increases as you go there. And then it is also above the horizontal line. Why? Because a is positive. So k or a or r, it's just a variable letter representing a certain number. All right, guys. That was a quick revision. I hope you still understand that. You click in here so that we can solve it. All right, here we are. So let's go back to the question. So on the question, they say the first point says 5.1.1. It says determine the value of k. Determine the value of k. So you have g of x equals to k to the power of x. Now they want us to find the value of this k, the number that is represented by this k, the number that this k represents. And you know, to solve something to solve this k on this equation, we need to find. Remember, guys, this is just a representation of the y value. It simply means for this graph of g, when x is a certain number, you will have a y value corresponding to that x. Like for example, when x is 2, y is going to be 36. So don't get confused. So now we need one coordinate here so that we can use to solve for k. So we'll use on the graph of g, we will use what? 2 and 36. That point there, that coordinate at that point will help us solve that variable k. So let us solve that, the value of k. And we know that k is positive because it is greater than 0 there. So 5.1.1 g of x is equals to k to the power of positive x. We need one point to solve. We'll use that coordinate given 2 and 36. 2 and 36. So now we need to substitute the values here, the values, this coordinate into the equation to solve for k. So we'll say 36 is equals to k to the power of 2. So we need k, guys. How can we remove this? This is 2, this is to the power of 2. So we can remove this by applying the square root on both sides. I'm going to apply the square root on both sides. So the square root here will cancel that. And then the square root of 36, guys, is what? Equals to. So the square root of 36 is plus or minus 6. This is plus or minus 6. Therefore, k is equals to what, guys? Positive. Here it says plus or minus. So for us, we know that k is equals to positive 6. So k is equals to positive 6 because that is what we were told. So it has to be positive. So here's the answer, guys. This is the value of k. This is of k. All right. Let us go back to the next question. So the next question, they say, give the equation of g to the power of -1, which give the equation. Sorry guys, we'll continue here. They say give the equation of the inverse of g in the form of y is equals to. So now we need the inverse of g. Okay, let's come here. So we had our g. Let me write g in terms of y. It was equals to 6 to the power of x. So now they say write the inverse of this. So guys, when you are doing an inverse, the first thing you do when you want to write the inverse of a function, you swap x and y. You swap x and y. So the first line is going to be swapping x and y. There you go. That is the first point. And the second line that you're going to do now is now you are going to solve for y. You're going to make y the subject of the formula. You're going to make it in terms of y is equals to. So now when you have this, we need to bring y down. Well, how do we do that? Go back to the logs, the laws of logs, guys. Remember that. So now I'm going to apply the log. So I'm going to have log of x is equals to the log of 6 to the power of y. Allow me to say equals to here. So when you have a log, you are allowed to take the y, that exponent, and bring it in the front. I think this is also included on the laws of logs. Check the video I did for the laws of logs. So this is going to be y is equals to, sorry, this is going to be y log of 6. So we have log x and y log of 6. So let me so guys, let me remove this part so that it does not confuse us. So this came from that. So now from here we have this and that. So let us, because we want y, divide both sides by log 6. 6 log 6. So what will remain with this side? Going to remain only with y. So I can say therefore y is equals to log x over log 6, guys. Y is equals to log x over log 6, which is also equals to, remember, there's a rule for this. I think it's rule 5. When you have this, you are allowed to write it as log of x base 6. Log of x is 6. So y is equals to this, or y equals to that, is the same thing. This is the equation of the inverse of g. So this is the inverse of that. Remember, the first step is to swap, then apply your log, and then solve for y. Solve for y, guys. So this is the solution to 5.1.2. Now we're gonna go to 5.1.3. 5.1.3. Alright. For 5.1.3, guys, they say for which values of x is g, for which values of x is the inverse, is this inverse less than, is the y value of the inverse less or equals to 0. So they're saying for this graph here, for this graph, which x values, for which x values will this graph, the y value, be negative? The negative y's are on this side, right? You go the horizontal line, you know the negative y's are on that side. So they want us to know for which x values. So we know, guys, the graph, the log graphs, as you will see on the first video that I did, the log graph, when it is like this one, it does not touch the y-axis. It does not touch the y-axis. When you say log of 0, it is error. It does not touch. It approaches that, but it does not touch it. that line becomes an asymptote. It cannot touch that line. And we see here that there's here somewhere where x is a certain number, y is going to be 0 here, because it is intersecting, it is cutting the horizontal line. On top of a horizontal line, y is 0. We know y is 0. That's from 0, 1 going up, or 0, -1 going down, but it is 0 here. So at a certain x value here, y is 0. So we need to find that, and we know that our x values for where the graph is negative, where the y values for the graph are negative, is going to be between the 0 line for the x and then this point here. Because they say less or equals to some here. So now we just have to solve that. So we'll say y is equals to the log of x, that is the equation, over log of 6. So they say this has to be less or equals to 0. So they are saying this has to be less or equals to 0. So we only have to solve this x value here, then we will be fine. So when I solve this, I will just cross multiply that, then I will have log of x less or equals to, when you multiply log 6 and 0, you get 0, guys. You get 0. There you go. And 0 is the same as log 1. This is a rule on the logs. I also gave it to. It's a rule. So when you see 0, you can also write it as log 1 so that you have logs on side. So I'll make this log of x less or equals to 0. I will write it as log 1. It's a rule. Please check the laws I gave for the logs. So now I have log on the left side, I have log on the right side. I can remove the logs. I can remove the logs. And then I remain with x is less or equals to 1. There. So I've solved that value that we said is going to be here. So we know here the x value here is 1. The x value here is 1. And then this graph does not touch this horizontal line where x is 0. So it means that the negative y values for this graph will be between 0 and 1. So I'll write that. So I'll say, therefore, 0 is less than x, and x is less than or equals to 1. So the values of x will be greater than 0, and they will be less or equals to 1, because 1 is included. They use the equals to sign. Or you can simply write this as 0, and then you say 1, and then close concentrated bracket. This is open bracket because 0 is not included. Close concentrated bracket because we include that one, and write it like that. So that is the solution for that part, guys. Okay, let's go to the next question. We go to the next question. For the next question, the number 4 here, it says, write down the domain of h if h of x is equals to the inverse of g minus x minus 3. So remember, guys, I told you, let me go back. Remember, I told you the other day that when you have a graph like this, we'll say y equals to a to the power of x, for example, minus a certain number to that x, or plus. I said, what happens here? This number here is going to affect the graph like this. The graph will move horizontal, sideways. I said, if it is negative, the graph will move to the right by that unit. In this case, the whole graph will move to the right by 1. If it is positive, the graph will move to the left by 1. And I said, if you have a number here at the bottom here, this will mean the graph will move vertical. Understand? Vertical, up and down. Positive going up, negative going down. So in our case, we are given x minus 3. See that x minus 3 as one thing. So there it's like this part. Instead of saying a to the power x, they are saying x minus 3. So meaning that 3 is not at the bottom, it's at the exponent. It's at the exponent, meaning it's gonna affect the graph with the horizontal movement. It's -3, meaning the graph will move 3 units to the right, guys. If it's negative, the graph moves to the right. It's positive, the graph moves to the left. In this case, -3, the graph will move to the right by 3 units. Let's do that. So the graph of G is G prime. The graph of the inverse is equals to log of 6. It was of x, right? But now they're saying h is equals to log of 6 but x. But now it's not only x, it's x minus 3. So meaning the graph will move to the right by 3. The graph will move to the right by 3. Graph will move to the right by 3. They want the domain. The domain is the x values, guys. So for the original graph, let me plot the original graph. The original graph was going to look something, we know, we saw it. It looks something like this. We know it does not touch this line, and here it's 1. So let me draw. So now when you move this graph by 3 to the right, it means this point has to move 3 units. 1, 2, 3. So it's going to be 4. Going to be 4. So meaning this is going to be the new point of this graph. So let me draw it. It's going to be like that. But it's the same graph, same shape, same everything. So it's going to be like this. So we see, what does this tell us? The graph now will not, this graph will not touch this point, which is 3. Because here it was 1, it was not touching 0. From 0 to 1 is 1 unit. From 4 to 3 is 1 unit. So now the graph shifts, it creates a new axis there. So the graph will not touch 3. So the graph now, the x values for this graph has to be greater than, they have to be greater than 3. Because if you put in log of 3 minus 3, it is the same, log 3 minus 3 is the same as 0. So this is the same as saying log 0. And log 0, it gives you error. So in order for this function to be possible, you need a value that is greater than 3. I hope that makes sense. So the domain, sorry guys, this is not P, this domain. Domain here is going to be x element of real numbers, guys. And then we're going to say x is greater than 3. So for the graph to be positive, for the graph to be possible, the x values have to be greater than 3. So meaning any number greater than 3, you will have the y value when you substitute. But any number 3 going down to the negatives, when you substitute, it will say error. So this is the domain. And then any number above 3 will give us that. That is going to be a possibility. That is it, guys. This is the answer for 5.1 point. I think it is 5.1.4. 5.8. That is 5.4. Now let us answer 5.2. Let us quickly answer 5.2. Let me add a page here. So 5.2, they're saying 5.2.1, it says sketch the graph of the inverse of y equals to 1. Let us first start by writing that the inverse y equals to 1. Y equals to 1. What do we do, guys, when you do the inverse? The first step when you do the inverse, is what? Is to swap x and y. So in this case, let us do the swap. Okay, we have y, we're going to swap it with x. Is equals to, we have 1. Do we have any case where we have x here that we can substitute with y? No, we do not. So we're going to leave it like this. So the inverse of this is this one. The inverse of this graph is this graph. So now they want us to plot this graph. So I'm going to do the Cartesian plane, and I'm going to put the 1 there. So they want us to draw that. You can see it is just simply x is equals to 1. X is equals to 1 is here. So you'll just draw a line there because x is equals to 1, guys. It passes through that. There's nothing we can do. It's just as that, something like that. This is the inverse of that. For this one, when you draw it, it's just going to be y equals to 1. It was just going to go like that. But now the inverse is x equals to 1. It goes like this. And then they ask us, sorry, this is 5.2.1. On 5.2.2, they ask us a question. They say, is the inverse of y is equals to 1 a function? Motivate your answer. Motivate your answer. Let me go back, guys. A function is a graph that passes the vertical line test. Meaning, if you have something like this, and then you decide to draw a vertical line, on that graph. If that line touches the graph only once at one point alone, then it is a function. But if you have something like this, and you do a vertical line like that, you see it touches the graph on 2 points, then that is not a function. So in this case, this is a function, this is not a function. So now for us, for our graph, this one, they are asking if this is a function. Let's do a vertical line test on top. There, look, when you do a vertical line test, it goes on top of the line, meaning it touches the graph, it touches the line from the top going down, making this not to be a function because it touches it too many times. It touches it here, it touches it here, it's directly on top of it. So this becomes, it's not a function. So we say no, it is not a function. And they say why, they say motivate. Then you'll simply say it fails the vertical line test. It fails the vertical line test, failing, it fails the vertical line test. It fails the vertical line test. So meaning when you draw the vertical line on top of it, that vertical line touches the graph too many times, so it is not a function. This means that one value of x, this one, is associated with many y values. It is 1 and then it's 1 and 0. It's 1 and 1. It's 1 and 2. It's 1 and 3 because it is exactly on one line. So that cannot function, guys. So this is the solution to the question that I gave you. Please go through this recording, guys. If you have a question, you are allowed to ask questions, guys. Please, I will send another question and I will upload the recordings for the hyperbolic function. So this is the exponential and log. Thank you, guys. I hope this was helpful.